In this video, we will learn how to work with t-distributions. We are going first to use ALEKS calculator to help us answer these questions. And there are two different kind of questions we need to answer. First, consider a t-distribution with 24 degrees of freedom and compute the probability that t is greater than or equal to negative 1.41. This means that I'm given a t-value and I want to know the area to the right of that t-value because the probability has to be found when t is greater than or equal to negative 1.41. To do that, we are going to use a feature in ALEKS that has a function like that pre-programmed for us. I'll show you how that works in a moment. The answer is already written here, but I will demonstrate with a video below right here how we can use ALEKS calculator to do that for us. Second story is different. Consider a t-distribution with 2 degrees of freedom. We need to find value of c such that probability that t is between the negative c and positive c is equal to 90/100th. Please notice it means I don't know what these two boundaries are, and I probably need to write that down. So negative c and positive c, here we go, that separate 90% of data in the center from the remaining 10% equally split between two tails. Again, the calculator will do that for us because ALEKS has a function t sub 0.05 in this case, or t sub alpha in general, where you enter how much area there is to the right of t that you're seeking, and that will give you a value of t. One word of warning with ALEKS: this function, probability of t being greater than or equal to some number, ALEKS does the greater than as its pre-programmed function, so it doesn't do the less than. So be creative if you have the inequality opening the other way. You can use always the complement approach. So let's see what ALEKS does. I'm opening a calculator and I'm using p of t greater than something. Notice I need to enter the boundary point of negative 1.41 and specify degrees of freedom of 24. And this gives me 0.914 rounded to 3 decimal places as requested. Then clear your calculator and let's use the second feature. As you can see, it says t sub empty spot, so you need to enter how much area there is to the right of this unknown t, enter the degrees of freedom, in this case 2, and it gives me 2.9, well, 3 decimal places, so it must be 2.920, and that is it. Let's check the solution. It worked great. This is how ALEKS works, and this is what kind of tools it is offering for you. Now I would like to solve the same two problems with the help of TI-84. To find the area under the t curve, you're going to use a function called tcdf, which is found under the distribution menu. You access that by clicking second vars, and that will take you into distribution menu, and you need to choose option 6 called tcdf. Enter lower and upper bound of your interval and the degrees of freedom. To find the t value corresponding to a certain area to the left of that t value, you are going to use function called inverse t. It is found in the same location by clicking second vars, which takes you to distribution menu. Choose option 4 for that. So again, let's go back to the example. Probability that t is greater than or equal to negative 1.41 is equal to tcdf with an interval starting from negative 1.41 going up to positive infinity with 24 degrees of freedom. When you enter this into calculator, it will give you this result. To find value c, so that there is 95% of data to the left of it, and that is the c I am referring to. As you can See, there is 90 plus 5, 95% of area to the left of this location. Therefore, I'm entering 95 and 2 degrees of freedom into function inverse t, and that will produce this result. Let me demonstrate that with TI. Second, vars. Scroll down to option 6 or just click 6. To use TCDF function, enter the lower bound of negative 1.41, upper bound of positive infinity, which we enter by 1 second EE 99, which really tells your calculator it gotta be a big number, degrees of freedom 24. Press enter a few times until you have the result. Round to 3 decimal places to get 0.914. To get inverse t, press second vars, choose option 4, enter area to the left of the t value you are looking for, 0.95 in this case, degrees of freedom 2, and press enter a few times again. Round to 3 decimal places this result and you get 2.920. Here is another example. Again, in first case, we will be given 2 t values and we would like to compute the area between them. And in the second example, we will be given the area and we would like to find the corresponding t value that separates that area from the rest of the curve. Consider a t distribution with 8 degrees of freedom. Compute probability that t is between negative 1.56 and positive 1.56. Round your answer to at least 3 decimal places. First, let's get the diagram for this scenario. As you can see, I have negative 1.56 and positive 1.56 as my 2 boundary points, and the blue area is what I'm really interested in. If I am using ALEKS tools, I don't have an ALEKS tool that gives me from 2 as my interval. It only can compute area to the right of the given t value. So I have to be more creative. To answer this question, what I'm going to do is I'm going to find area to the right of negative 1.56, all of it, including this tail in pale pink. Once I find all of this area, I don't really want to include this pink area in there, so I'm going to find how much it is by using the same tool, probability that t is now greater than positive 1.56, and I will subtract this entire area with the tail minus area in the tail only, and that will leave me with this desired blue shaded region. The answer will be 0.843. I will demonstrate in a minute how we do that in ALEKS. My second story, consider a t distribution with 15 degrees of freedom. Find the value of c such that probability of t being greater than or equal to c is 1/100th. What it translates into visually is that I have a right tail with 1% of data and I want to know what t value does it. This t value is, well, in ALEKS language, they call it c. So my value of c will be t sub 0.01, or t with 1% of data to the right of it. Again, we'll just have to use ALEKS tool to compute this. Let's take a look. So I'm opening calculator and let's clear what I had there. I need to first enter probability that t is greater than negative 1.56 first. So probability t is greater than, enter negative 1.56, make sure to include degrees of freedom, 8, and get outside of the parentheses and subtract another probability that t is greater than positive 1.56 with degrees of freedom, 8, and press enter. This gives me the difference of 0.843 when rounded to 3 decimal places. To find t value that separates 1% from 99% under the t-curve, I'm using the t-sub tool, which is right here. So t-sub what? 0.01 to the right of that t. Degrees of freedom is 15. Press enter, and we're done. 2.602 when rounded to 3 decimal places. Let's type in the answer and check to make sure we agree that this is a right answer. Yeah, it worked. Let's do the same example again using TI-84. Probability that t is anywhere between negative 1.56 and 1.56, we can use TCDF, where we indicate the boundary points of my interval. Here it's pretty straightforward. Include degrees of freedom, get your answer of 0.843. To find the C-score that separates 1% from 99%, remember TI-84 works with area to the left, while ALEKS works with area to the right. So pay attention to which tool you're using. So C value will be computed by applying inverse t to 99% of area to the left of this t value with 15 degrees of freedom, which produces 2.602 as the result. Let's see that demonstrated. Second, VARS, option 6 for TCDF, lower boundary negative 1.56, upper boundary of positive 1.56, degrees of freedom 8, and the result is 0.843, just like we expected. Second, VARS, option 4 for inverse t, area to the left 0.99, degrees of freedom 15. Press enter a few times after that, and let's see what we have. 2.602 as we expected. Now you have seen how to find both of these quantities, whether it's area under the t-curve or t-value corresponding to a certain area, using ALEKS calculator and using TI-84 calculator.